Hi, everybody. Welcome. My name is Ann Magger. I'm the Dean of the College of Business Innovation, Leadership, and Technology. We've got three schools. We have the School of Business and the School of Technology and Innovation. It's not unusual for those two schools to be combined at a small university like Marymount, but what really makes us unique is that we also have the School of Design and Art as part of our college here. So it's an exciting place to be right now. We have a lot of great students, great faculty, and we also have a lot of great alumni. So we're really excited tonight to be able to welcome Suresh Nair, who is from the class of 2009 and is going to be talking to us about emerging technologies. So this is the point where I have to read from the notes that I have here. Suresh is the president and CEO of ENA Solutions, where he leads work in digital transformation, artificial intelligence, and quantum computing. He brings more than 20 years of experience in IT solutions and technology strategy. In addition to leading his company, Suresh serves on the external advisory board for the Monark Quantum Foundry, and I don't even know what a quantum foundry is, so I'm hoping we will learn about that as we go, and as a board member of the National Quantum Literacy Network, both supported by the National Science Foundation. And his team also recently received an NSF award in quantum machine learning. We're proud to have Suresh as part of our Marymount alumni community. We're grateful that he's here with us tonight. So please help me welcome Suresh.
Good evening, everyone. Thank you for the opportunity today to come and speak to you all. Thank you to President Bracera and Katie and the team to invite me. And thank you all to come on a busy day, a weekday after college, full class, and come and attend the event today. So I appreciate it. My name is Suresh Nair, and thank you, Anna, for introducing me. I appreciate it. And I have Dr. Murphy here. Thank you for coming. She was one of my mentor and teacher when I was here. Thank you. So my topic here is, let me little talk about the company itself. ENA Solutions. ENA stands as a Sanskrit word. It stands for bold, innovative, infinite. The reason why I picked that the name is as the technology changes and emerges, we didn't want to put ourselves in a box and the name gets outdated, right? So that's the reason why I picked ENA. We are located in Tyson's Corner, Fairfax. We have been in business since 2011. So today, I will be speaking about designing a career in AI, data, and innovation, and also tie it up to people, because if it's not about people, then there's no value, right? So let me go through it. So let me start off who I was entering Marymount, right? I was actually a full-time professional. I was a senior developer, and I worked in a building behind this building, CSCI. It was called Khaki Building. So I was not a traditional full-time student here. I was a part-time student. So it was pretty easy for me to finish the job, go for a run, take a shower at the gym, and then come and attend the classes here. So I also was starting a new family, right? My son, we had a son, wife and I. So this was a perfect place for me to come and complete the classes and go home, right? So part-time student, working professional, and figuring it all out. So I had no idea what I was getting into. My background, I was born and brought up in India, Bangalore. So my education, my graduation was in mechanical engineering. I worked in the aerospace industry as a design engineer for designing parts for wings, aircraft wings. That was my first job. And then I got into the data, and that's the reason I got interested into technology. So when I came here at Marymount, I have no idea what I was getting into, right, from a master's program. So I was doing master's in information technology management. So I needed a part of information technology in master's and also the marketing aspects of it. So it was a perfect mix. So what did Marymount give me, right? First thing is confidence, right? Because I'm not a native English speaker, right? So presenting something which I know in confidence, it's hard, right? If you're not a native speaker, right? And now you have AI and all that stuff, you can come up with papers. But Marymount really gave me an opportunity to learn the subject and, present it, in a presentation format. Had no idea how, even in my undergrad, we didn't do that much because it's mechanical engineering. So that opened a lot of doors for me, like, from innovation perspective, right? And one of the classes which I really enjoyed, along with Dr. Murphy's classes, cybersecurity and also marketing, right? There was a marketing classes where it challenged me to go research and look at some of the topics and market the product, right? So that gave me a good idea of how do I take my background in IT and create something new, right? So that was a really good experience for me. So I had a great community here because since I was starting off my career, I also had seniors in my classes as peers who were the leadership positions in different companies. So they really mentored me. So after the classes, we just sit and talk about, what are the next steps and stuff like that. So they really mentored me. So mentorship was a big deal. And it was a place to grow because it gave me an opportunity to fail and succeed. Because you know what I'm saying? Like, I was not afraid of failing, right? So those are the few items which I would definitely reflect on. So why I wanted to build something, right? So I was always curious, whether it was mechanical engineering, the aerospace industry, or doing IT, right? My job was great at khaki, doing great things, solving bigger problems, challenges. But at some point, it got routine, right? So when it gets routine, then you want to break the status quo and think, what do you want to do next, right? So I kind of put a 5-year, 10-year, 15-year kind of vision where I want to get to, right? And how do I get there? So decide to make impact. That was always my main motive. That is, whatever I do should have an impact to what I'm doing, right? To the people as a value, right? A few things that truly matters early on for me was, as I mentioned, curiosity. And then ask questions and smart small. So why that is important is because if you're curious, and for all the young students here, right, I think that's the driver, right? You got to always be curious about what you want to do next. That curiosity lets you to get up from a chair and take the next step. Okay, so that's happened to me, right? So when I was doing my regular job, having a young family, I always put time apart to say how I can network. So I went to the events, network. So I met a bunch of folks from Navy, right, who were retired captains. So they really, after a few meetings, they saw some in me, right, their capability, and they didn't have the technology. So they really took me under their wing. Because the reason why I liked it, because they had the administration skill, leadership skill, and they were disciplined, right? They were in 60s when I was in my 30s, right? So that really gave me a way to look at things differently, how to look at from a bigger enterprise perspective, right? So that really gave me an opportunity to get into the network, but the initial starting point was curiosity, right? If other people can do it, I can do it, right? So that, and I didn't want to start something new at that point because I never ran a company of my own before. So I wanted to get in and learn from how it's been run the right way, right? So before starting Solutions, I joined this bunch of folks whom I knew through my mentorship. They started a company and they tried to bring me in as an employee initially. So I negotiated saying, I don't want to be an employee, I want to be a part of the company. So they brought me as a part of the company, as an owner, right? And that led me to sit on the board meetings and stuff like that. So I got the technology aspects of it, how to run operational, right? And meet the clients and solve problems, but also I got the opportunity to lead the company, right? Make decisions. So I did that for 7 years. And one of our main contracts was a Department of State to modernize the data for all their overseas operations. So I did that for 7 years and then decided to do my own at some point. That was 2011. So that's when I started in a solution. So when I took a break for 6 months and tried to figure out what I want to do, I didn't want to get into anything which I was not good at, right? So data was my key strength. So since data was my key strength, I looked at and kind of analyzed, will this be sustainable 5, 10, 15 years? And I heard the talking about AI and stuff like that. And it was a perfect timing because that's when the gaming industry came into mainstream, cloud. So it was a perfect mix of everything coming together to make this a reality, right? So I started off with the data analysis, dashboarding, visualization, all those kind of features initially, right? So I was looking for a first client, and it's always hard to get the first client, right? So what we did was we went with the collaboration with some of the guys whom I knew. We put a good white paper for SBIR. SBIR stands for Small Business Innovation Research Fund, right? So they give you like phase one, $100,000, phase two, $1 million, and phase three is bigger, right? So I met a colonel from DLA, Defense Logistics Agency, was retired, and he had a small veterans-owned company. So he had the subject matter expertise, right? He knew the problem in DLA. One of the key problem at DLA they had, this is way back, is jet fuel analysis, right? So at a base, if they have, before they fuel a jet engine, they need to sample the fuel. And it takes months and weeks to get in some locations. So we came up with an idea of putting a spectroscopy together. So spectroscopy is an instrument which uses light to measure any kind of fluid. So we developed a spectroscopy as big as a cell phone, which goes on the field officer's belt. And then we build an AI component to it to pull the data into a mobile app. And we submitted the proposal as a concept. It was approved. If we got $100,000, then we got $1 million. That gave us a lot of background of how this things all works. Then from there, we wrote a white paper to DHS, the Department of Homeland Security. And it was a problem they were trying to solve for the last 5 years. It is building knowledge graphs for billions of attributes of people who have applied for benefits. So they have like 50 or 60 Oracle databases, terabytes of data, but they don't talk to each other. So we wrote a white paper, we got down selected. We've been there since 2022. We're building that solution out there. So it's a complete AI solutions, right? So you start small, right? And then you grow into that. And so it all started from the same subject, curiosity, right? So what we do today, I talked a little bit of the AI solutions. We do support some of the major agencies out there. Data engineering, we do for even commercial clients also. And some of with the collaborations with academia. We have a good relationship with the Cal States, the local George Mason, and we're trying to build some relationship with Marymount now. So even the academia also makes a big difference of what we do. The last piece is quantum, and I'll come to that in the next slides. So why emerging tech matters? For most of the students here, it really matters because as you all know, that AI is changing the workforce, right? What you're studying today is something different from what will happen tomorrow, right? So it's very important to keep up to speed with that. So everyone in this room are using AI in one shape or form. Right? On your mobile phone, or you order Uber, or whatever it is, right? So we all know about AI. So data it makes better decisions. You have multiple Excel spreadsheets today using Copilot. You can throw up a dashboard in two minutes, right? Writing a prompt and you get a dashboard. Quantum is something. How many of folks here know about quantum or heard about quantum? Good, very good. So this is going to be, it's going to not going to replace the classical computers or classical way with the AI we are doing today. It's going to be an addition to what we're doing. So in a really plain English, apologize if anyone is here. I'm not trying to offend any quantum physicist here, but this is plain English to make folks understand what quantum computer means. think about a switch, right? You have on and off, right? So that's your zero. One is on, zero is off. Quantum is like a dimmer, right? You have zero and one, and in between, right? So classical zero and one is bits, and quantum is qubits, quantum bits. So because of that dimmer possibilities, you have a lot of possibilities, and that gives you optimization. So that's pretty much in a very basic level. If I have to explain what quantum means, that from a bit and qubit, you compare between a switch on and off and a dimmer, right? From a probability perspective. So this is a visualization of the same. So you see classical AI on the left and quantum AI on the right. So if you have a maze, right? So the classical AI today, the neural networks will go sequentially, so step by step to the goal. Whereas quantum will give you all the path at once, right? So instead of going sequentially, you'll get the result instantaneously. It's not there yet. There's a lot of errors. It's not a perfect system. But also, like if you look at some of the media, Google did something. They have not published it and they're not certified it. We're using the Willow chip. They did some computation which takes probably 10 to the power of 25 years on a classical computer. They did it in a couple of minutes or hours, right? So that's the speed you're talking about. And why is this important? Is because for drug discovery, it's important. Diseases like Alzheimer's, you could do some, using AI simulations, you can come up with new drug discoveries. Our company we are working on a use case with Cal State to use quantum AI to simulate quantum 2D materials. So quantum 2D, like Anna was talking about the Monark, right? So Monark is a collaboration between Montana University and Arkansas, funded by NSF, on quantum 2D materials. So why is that important? Is because 2D materials is very, thin, and the devices become smaller, the quantum sensors and stuff. So we are actually working with Cal State to use quantum AI to create the simulation so that you could figure out new spins within the atoms and stuff. I'm not a physicist, but there are folks working on it, and they understand better than I do. But they're getting closer to something, but not yet. And we got an opportunity to present this at Oak Ridge Lab last year. Okay. So opportunities in emerging technology. So that is where, as a company, we are going to the next step. I solely believe that as emerging technology evolves, you don't need to be an expert in certain fields. Just like how I talked about spectroscopy, the kernel had a problem, right? I was the guy who came up with the solution, but that me can be replaced by AI today, right? So I don't know if you saw the news. I think the company called Perplexity, they have launched yesterday a platform called Computers, right? That is a digital worker 24/7 in the cloud for you, just like your local computer. So you can have all your data in the cloud. It'll do with all your AI agents. You can tell them as a prompt, and it'll do everything for you, right? So if you are a subject matter in, say, for example, in the music or art, right, or even a plumber or whatever it is, and you want a particular instrument or sensor to be created, you could use AI to do this today. You don't need to know the coding. You don't need to know, how to design it from scratch, because you can get that help. So you don't need to be an expert. Same thing with quantum. So when you talk about quantum, we're not trying to create quantum physicists, right, for the workforce. We're trying to create people who can handle, for example, quantum sensors. There will be workforce where we need to create even the cases for quantum computers, right? Cryogenics, all the different parts where it doesn't have to be a scientist doing it, right? They need to understand it. So I'll come to a slide where I'll speak more about it. So this technology is for everyone, but you got to be curious. So how to start, just like how I did, and how did I get into quantum, right? I'm not a quantum physicist, right? I'm a mechanical engineer, right? And then I learned, took masters in IT management. How did I get in? So I was reading about it. I was curious about it. And then I have some relationship with Oak Ridge Lab, and there was something about cybersecurity and quantum. So I wrote a white paper to IBM, and that's how it started, right? So I showed the way how you can use cybersecurity logs and use quantum AI and figure out a path and all that stuff. So that led to one after the other, and then that's why where we are today, right? So we took a problem, learned one tool. So we didn't try to get all the tools out there in quantum. We went with IBM Qiskit, find one mentor, that was IBM, right? And build one thing, which was the cybersecurity use case. My purpose today, as I stand here, is building pathways. And I'll talk about it in the next slides. Opening doors for the younger generations, and then, tying up everything to the people, as I spoke before. Make tech inclusive. So this is a very good slide. I'm always proud what I've done. The NSF Excellent Grant, the way we got it is because we started off with George Mason University here. For 3 years, where it was not funded, we hosted high school students from DC, Maryland, and Virginia on 2 weeks of quantum AI, right? So our staff members virtually taught 2 weeks with a STEM background or non-STEM background and gave them a project, and end of the 2 weeks, they had to do a presentation, right? So with that experience, we wrote an NSF grant. So when we write an NSF grant, NSF doesn't give it to in the industry like us, right? So I brought in Tuskegee, Alabama, ANA, UDC, GMU, and California State, USC, University of South California. And then a few nonprofits like National Quantum Literacy Network, Montana, all those folks. So we were the prime. So the first time when we wrote it, they denied it because it's an industry. The second time, we wrote it again. We took all their advice. We published it back again to them. It was awarded. We got $1 million. And this is to train all the undergrad students, 165 students for over 3 years. And this is one of the award ceremony at Alabama University. I think it was co-head of 8 people for 6 weeks. And this is their certificate ceremony. And this is how I just took a screenshot. Some of the folks were from the STEM background. So this is quantum computing and drug discovery. For 6 weeks, they went through the online hands-on programming, and then they created a few prototype use cases. And some folks were not from STEM. Some folks were from actual marketing, like MBA. So they really, really valued it because now they know what quantum computing means and why is it important to learn that, right? And they also were part of this, and they did the presentations also, very good presentations. So I'll just go over this real quick, and I'll show you what we are doing with this. So as the name, this is a platform which is live on AWS today. We developed it using AI and generative AI, completely homegrown, no vendor lock-ins, in collaboration with a lot of multiple organizations. One is National Quantum Literacy, South Carolina Quantum Consortiums. They funded us for this. So let me just give you a little bit of, it's going to be loud. Apologize if it's too loud. There's a promotional video here. And I'll tell you why this is important is because this is targeted to, or this is, the goal is to train 8 to 12 graders in quantum, right? To bring, to bring in all this community, which can otherwise won't have an opportunity to do this, right? So I'll just not at the physics expert level, but what quantum means and why they need to know it, right? And I'll show you a promotional video. So that's the platform, and I'll just show you a simple.
Hello there. How are you doing? We'll be guiding you in this learning session on classical and quantum theory. In this, we will cover key concepts about classical and quantum physics. Some of the topics you will learn will be classical physics, superposition, entanglement, spooky connections, birth of quantum physics, wave-particle duality, uncertainty principle, quantum tunneling, among many others. If you need any help, just ask our AI Q-bot. Let's begin this exciting journey.
So this is all based on micro-credentials. And
welcome to Quantum Literacy
like 30
Education.
second, 1 minute videos for the attention span.
Today, we're starting an amazing adventure into the world of quantum technology. This is where you'll see the secrets of the quantum world come to life and learn how it's changing our future. We'll start with classical physics, which we all know and can easily relate to. Great minds like Sir Isaac Newton came up with the rules of classical physics, and these rules explain how things work in our everyday life. For example, they tell us why a ball falls back to the ground when you throw it up, how electricity lights up our homes, and how cars move on the road. But as we continue, we'll come across new rules that will shake up what we think we know.
So this is accessible over mobile phone, iPads, whatnot. We have already 2 customers. One is the Governor Schools of South Carolina. We onboarded 200 students over in January. And then we got an award from the entire state of Montana. It's Montana Digital Academy, a collaboration with a nonprofit and the state. So we're trying to build an API so that it goes on their learning management system. We also got a lot of interest from a lot of community colleges. So it goes from simple to tough, like advanced one. And we're trying to use this. The next version of this is virtual reality. There's a lot of interest. As I was driving here, we pitched this for AI Challenge. It's actually funded by Melinda Gates Foundation for $5 million. Actually, we got down selected for that, using the same platform but teaching AI for mainly for women and including women into AI workforce. So there's a lot of opportunity there. So that's what I'm saying. Curiosity is what makes a difference, right? And I'll conclude here by just showing this conference here. So we are chairing this. This is a collaboration with a lot of different companies and California State. It's going to be on 15th and 16th. It's very important if you're in the workforce development area. A lot of good speakers, a lot of people from Pentagon agencies, IBM, you name it. They're all going to show up. And it's 2 days event in California. Highly recommend if you're interested in workforce development. So I think they already expect like 500 people already registered. It's a great opportunity to connect. There's going to be a lot of good companies. And this gives an opportunity even for students who are willing to come and do some great networks. I hope that this made sense. Almost towards the end of my presentation here. There you go. That's me on LinkedIn. If anyone wants to connect with me on LinkedIn, please do. And thank you for the opportunity. I hope this made sense. Thank you.
Thank you so much, Suresh. This was really great. And thank you all for coming. We do have a reception happening on the second floor of the building. So we would love if you could join us there, and you have the opportunity to also ask some more questions from Suresh. Thank you.